Yeah, hello everyone. Welcome to my talk, Security at Your Fingertips. A dive into Marshmallow's new fingerprint and keystore APIs. I think some of you, or at least some of you, have like a new phone in their pockets, which is like running Android Marshmallow or later. So I think it's kind of interesting for you. And yeah, let me start with the obligatory About Me slide. So yeah, that's me. It's Frederik, I'm Frederik Schweiger. I'm a computer science student sitting there at 30,000 feet at the edge of a plane. And if I'm not like doing skydiving, I'm mostly like going to work as a student employee with the mobile guys here at Schweiger. And when I'm not doing anything of both, you will probably find me at university. So yeah, cryptography. Cryptography is such a cool sounding word, but unfortunately so many people are getting it wrong. And not for nothing, like broken or no cryptography is one of the top 10 mobile risks for 2014 and in 2014 and 2015. And it wasn't really like in the top 10, it was always in the top 3 or top 4. And yeah, hand on your heart, whoever used like the Android keystore provider or some encryption in their app, like to store user data or user information, user passwords. Yeah, at least a few of you. So the question I want to answer in this talk is, how can I, like as an Android developer, store my user-sensitive information securely in my app? So, and this is like an elementary problem each of us will have or already got. So if you want to secure informations like login data or like tokens or whatever. And until now there was not that a reliable way to do this. But fortunately there is like the Android keystore. But well, what does it do? Yeah, it stores keys the secure way. But let's start at the beginning. Most of us provide like system services to securely store these authentication keys, and there's no need for developers to implement them by themselves. So Android 1.6 had like a credential storage for VPN and Wi-Fi, but unfortunately this whole storage wasn't accessible by apps themselves. So public key infrastructure was done by like via the settings app, but unfortunately if you want to build an app by your own, this wasn't possible like to use any certificate placed inside this store. Android 4.0 finally introduced like the public keychain API, which made possible like to install this type of certificates, and it was not possible like to access this system credential store. And unfortunately, all these keys were like system-wide shared. So if you want to have an application which only used like an app private key, so only for your private server, and you didn't want another company or another app to use this certificate, this wasn't possible. And additionally to that, this wasn't the nicest solution, because in the end you just had like an intent you were able to fire, and then there popped up the system dialog where you could select this whatever, like certificates and all this kind of stuff. And if you think about like this, that not every user is like has a technical background, it's not the best user experience for them. So in Android 4.1, they finally introduced like the keymaster HAL. So there was a huge change like under the hood in the Android architecture. And 4.3 finally introduced like the Android keystore. And the Android keystore is not like another Android specific API like the keychain. It's more based on the JCI architecture. So you can use all Java APIs to work with the keystore. And yeah, this keystore finally supports like hardware-backed credential storage, like in trusted environments. And the first device was the Nexus 4. And these app private keys were now possible through this implementation. Unfortunately, this implementation wasn't so clear to every developer, and sometimes the key data got wiped or it was broken when the user changed, like their log pattern or the passwords or whatever, and then the key data was corrupted, and the people you as a developer weren't able to use this certificate anymore. And now finally, Android 6 and Android N improved this drastically, and they changed everything under the hood and re-implemented it. I think there was a completely rewrite inside like the key master and keystore thing. And yeah, this talk will focus on the JCI keystore provider. And yeah, so maybe someone of you has already worked with the keystore API, I don't know. So you may know like the key pair generator spec class. So if so, you can like forget about it because it's deprecated since API level 23, and it's now called the keygen parameter spec class. So the keygen parameter spec class implements the algorithm parameter spec for the key pair generator or the key generator, and in the end, the key generator and key pair generator are just generator classes, engine classes, which are capable of generating private and the related public key material utilizing the algorithm they were initialized with. And the whole thing is instantiated by the keygen parameter spec builder. And this builder determines like the authorized use of the key, if user authentication is required or not, and what operations are authorized, like signing, decrypting, or encrypting, and with what parameters, like only particular padding schemes or digits, and the key's validity start and end dates. So let's just dive into a short example on how this works. To generate like the symmetric key, we have like the key generator class, which will be instantiated with the key property, key algorithm AES, and the Android keystore. And after that, we create the keygen parameter spec builder class, and we pass our alias of the key and our purposes if you want to encrypt or decrypt key material. It's very important to have like to specify all the purposes you want to, like if you want to decrypt or encrypt or to sign, because if you want to use that key, the keystore implementation only lets you use the key for this specified purpose. And here is how everything works. It's just a simple builder pattern. So you can set like the key size to 256 bits, the block mode and the encryption padding. So it's like all this encryption specific stuff. And after all, you just say key generator.init with the builder build and key generator.generate key, and the key is generated. And now we would have like the my awesome secret key 01 stored inside our key store. The equivalent for like an RSA key would look like this. It's just like the same, except that we have like the key property for key algorithm RSA, and the key property purpose sign, and like a calendar for start and end date, because every key inside the key store needs like a valid certificate, and it's creates it by its own, but you can replace it with a signed certificate from the certificate authority later. So yeah. So after that, we successfully created my awesome secret key 01. And if you want to encrypt something, it's super like straightforward. We have like we try to get an instance to the keystore with the Android keystore provider, and after that. We have this all relic of the Java cryptography API, where we have to call .load, even if we don't have like an input stream or whatever to load it with. But yeah, this is like the API of the JCA. And then we get the secret key from the key store and instantiate a cipher. So we say secret key, keystore, get key, my awesome secret key, And yeah, after that, we get the instance to our cipher with the parameters we specified in our builder. And after that, we can simply like initialize the cipher and encrypt and decrypt the plain text, and finally have this encrypted bytes array there. The same, it's more or less the same for like decrypting all the stuff. It just changes like the last row where we are initializing the cipher with the decrypt mode, and the secret key and the initialization vector, which was generated when we like encrypted our bytes. And after that, we say just cipher to final, and we have the decrypted bytes again there. So the key advantages of the new keystore are, it's like an OS provided safe for all your key material, keys and certificates. And we have like the hardware-backed cryptography and a secure storage and a trusted execution environment. So even if your device is like compromised by a hacker, or you have like super user rights, or doesn't matter, all the key material isn't able to be like extracted from the device because it never leaves the device. And now we can reliably and securely create and store app private keys, which was able like from Android 4.3 and upwards. But now they improved the whole API and the reliability of the thing. And yeah, they added support for some different like algorithms. You can look it up at the Android documentation for RSA, like elliptic curves, IES, and HMAC keys. So yeah, trust zone here, trust zone there, and trust zone everywhere. It's like currently 80 to 90% of all the devices already have like this trusted execution environment from Qualcomm. They call the trust zone. It's currently used for like digital rights management to play this kind of media. And the cool thing is that actually like 80 to 90% are already like having this kind of chip, or in this case, I think it's just like a different privilege level in the CPU. And the cool part is that this is a requirement of Android N. So every device which will be shipped with Android N has like a trust zone enabled CPU. So you can store all your key material inside it in the secure way. But as we all know, like the authentication is a bad user experience, and we want to get over it. So we're living in 2016, and Google is already like inventing self-driving cars and bringing the internet out to everyone with balloons. And finally, they introduced fingerprint support on Android. But let's start there at the beginning. Authentication, is annoying and is time-consuming, comes up too often, and almost 50% of all Android users do not have a lock screen enabled because of that. Because if you just like pull out your pocket, you just want to check your the weather or just your bank account balance, you always have to authenticate in every app, and this is what the users dislike. And the cool part of it, you can now integrate the authentication process inside like with the unlock process of the device. So if I pull out the device out of my pocket, I can check with the keystore if the user recently authenticated, and if it says yes, I can just like skip the login screen or the authentication screen in my app. So this is a really great way to improve the user experience there. So yeah, with these two methods, if you use it on the builder I just showed to you, you can just set user authentication required and set user authentication valid duration seconds to something. So if you're just saying, let's say 15 seconds or 30 seconds, when you're just like in this time span, you can just get the key material which is created like in the keystore without like authenticating again. And that's pretty cool. I show you how it works. You just have your builder pattern there, and you add these two parameters. And after that, you can, in this try and catch clause, where you usually would like initialize and decrypt your data, you have like another catch clause, and you can catch the user not authenticated exception there. And then you can say, the user is not authenticated, so let's do something there. So we could like show the user an authentication screen from the operating system, and this is called the create confirmed device credential intent. And you can also like customize this whole thing, and this looks like this in this app. This is, by the way, a demo app you can download on GitHub today. And this is how it looks like. If you want to encrypt or decrypt something and you're not authenticated, we get like this default lock screen behavior where the user can authenticate with their pattern, their password, or like with fingerprint. So you already have like the fingerprint option built in there if you don't want to build your own user interface. So on activity result, you check if the result is okay. And if the system says the user recently authenticated, you just try it again to get the key, initialize the cipher, and then try to encrypt or decrypt the data again. And then it should work without throwing the user not authenticated exception. So in the end, authentication just got easier because you don't even have to show like the authentication screen, which I just told you. You can just like pull the phone out of your pocket and go inside your app and skip all that. Just imagine it if you're like a bank and you want have like very user sensitive information like bank account information or how much money you just spent the last night or whatever. And this is pretty cool because the user has like an intent to just check his or her like bank account balance or whatever, and he can just pull out his or her phone and go directly to the app without authenticating again. And authentication just got stronger because authentication is now tied like to app secrets, so we can authenticate with the users and have the key store there. And all this credential verification does now happen in this secure environment or like trusted execution environment. So all this encryption stuff happens directly inside this chip, and even if the system is compromised, you can't interfere with it. So, but if you want to do like a more easier way, or you want to implement your own user interface, there's also the fingerprint authentication. And the cool thing about fingerprint authentication is that the authentication is now a lot easier for the users, and it's even more faster. And we have this consistent authentication flow in your own app if you provide your own user interface. And what's cool is that on Nexus devices with the fingerprint reader, with Nexus Imprint, this lock screen adaptation for secure lock screen went from like 50% to over 90%. So many more users are currently like using a lock screen and device encryption because of the fingerprint reader. And this is pretty cool because it's fast and the users like to interact with it. And by the way, keep in mind, if the device doesn't have like a fingerprint sensor yet, there's also the smart lock feature from Google, which currently reduces this lock screen or authentication prompts by 50%. So only every second time you have to authenticate on your mobile phone when the user has enabled smart lock, like this detection if you're wearing your phone with you or you're just having Android Wear Watch connected to your phone. So, but the key concept of like fingerprint authentication is that you can build your own dialogues for it, and you can adapt it to your authentication flow, and the user does not have to leave your app. So you can simply click the proceed to checkout or buy or whatever button, sign in button, and then your dialogue or whatever shows up. Or it doesn't even need to be a dialogue. You could also like implement it in your activity. And then you can just like tap the sensor and then you're authenticated. So make it really easy. Use fingerprints. What you need is like a fingerprint reader, a device running Android Marshmallow or later, and a user who is set up a secure lock screen and of course enroll some fingerprints. But this thing is optional because we can always force the users to enroll one. So fingerprint manager. This is like the class you have to use if you want to implement fingerprint access on your phone. It's like a system-level service, like any other service, and coordinates all the access to the fingerprint mechanisms. And yeah, you need to use the permission, use fingerprint in your Android manifest. And fortunately, it's not like a critical permission, so you don't have to prompt the user to allow access to your fingerprint. And yeah, this is pretty cool. So in the end, yeah, you just like have the code like this, the fingerprint manager, and say get system service, and then you're done. You have a reference to the fingerprint manager. And the fingerprint manager also provides methods to check for device compatibility, like is hardware detected or has enrolled some fingerprints. And if not, you can always say, yeah, please go back and check these settings and enroll some fingerprints. Or when the device doesn't have like fingerprints or a fingerprint sensor, then you can always say, yeah, unfortunately you don't have it, but you could also like use the lock screen approach there. And this class is also available as a compat version. So if you're running Android 22 API level 22 or 21, you could use the compat class. And then it says, yeah, there's no fingerprint manager or fingerprint reading available because the API level is like 23 or higher. So yeah, the fingerprint manager. The most important method there is the authenticate method, and it's like the last of those three. You can like check the device compatibility and authenticate. And the first thing you have to pass over is the crypto object, a cancel signal, which is nullable, some flags, which should be always null, zero. A fingerprint manager authentication callback, which you have to implement, and handler. And the handler is used for where like the fingerprint callbacks are called on which threads. So yeah, the fingerprint manager crypto object is more or less a wrapper class for the crypto object supported by the fingerprint manager, and has just these three simple methods like get cipher, get MAC, or signature. So it's pretty straightforward there. And the authentication callback provides like the whole callback structure, and you have these methods you can like implement. The authentication succeeded, where you get like this authentication result, and this result simply gets you contains like this fingerprint manager crypto object where you can get your cipher from or whatever. And the other three methods, like on authentication help with the different codes, are called when you just like when the user just swiped or tapped the whole sensor for too short time, or there's another error like dirty sensor. And authentication error is called when there's just an error or the whole authentication stopped. And on authentication failed is called when the user just used like a different finger or whatever, so the finger wasn't like recognized. So yeah, how does it work? On the authentication succeeded, you can simply like get the crypto object from the result and then decipher and work with it there. So if you just like set the authentication required to your key in the keystore, and you say the duration seconds or set the duration seconds to 0, then you always have to use your fingerprint to authenticate. This is pretty powerful, and good way to use this new method to authenticate the user within your app. So the best practices for a great user experience are the keys to use the keystore to check if the user authenticated recently, so you don't have to show an authentication screen again. And if the fingerprint sensor is available, I would always recommend it to use it, because the users like it a lot. And as you've seen, the adaption of the secure lock screen just went from 50% to over 90%, and it's a quick and fast way of like securely authenticating. And if you don't want to like implement your own authentication user interface and all this kind of stuff, you could always like use the confirm device credential intent, which you can fire, and which looks like this standard lock screen on your Android phone. So it's pretty cool there. So in the end, yeah, we have this short demo here. Yeah, I already shown to you. You can download it on GitHub, so you can play through all the different kinds of scenarios there, like that you don't need any user authentication if you want to just like store your information securely, create a certificate or whatever, and another one to like enable fingerprint, or that the user has to use the fingerprint sensor to unlock the app, or another one with the like 15-second interval, but it's completely customizable, so you could also use like, I want to use 30 seconds or up to 5 minutes or whatever. You need. So you can always like authenticate with the fingerprint if you have enrolled one. So yeah, the further reading I have here is like the developer training, of course, and what's very interesting if you want to do a more like deep dive into the Soul stuff, then it's the source.android.com security. Also a great book is Android Security Internals by Nikolai Alenkov. Unfortunately, this covers only like Android 4.4 and lower, but it's definitely a good read. So yeah, thanks everyone for coming today. And if you have any questions, you can always ping me like on Twitter or on Facebook. And yeah, that's it if you have any questions.
Or simply ask the questions right now. Yeah, that's what I wanted to say. Thank you, Frederik. Who wants the microphone? Yep.
Hi, thank you. First question is about what about the solutions from other manufacturers like LG? I think have something, and for sure Samsung for the devices before Marshmallow. Do they have the same patterns? Do they use the same solutions? How to handle all these cases? Can we combine them?
Yeah, actually, unfortunately, I don't know like how this works like pre-Marshmallow, because it's like, as you said, like manufacturer specific. And I can tell you how this works on like Samsung or like an AG device. But yeah, since like Marshmallow, all the manufacturers should like implement this API, the fingerprint API, and the keystore API. And in the end, it's up to the manufacturer to implement all these security features. So yeah, unfortunately. Yeah, it's currently like API level 23 and up, so yeah.
Did you see any, how fast is the performance of the GCA implementation? Because before Marshmallow it was pretty slow, like orders of magnitude slower than if you used OpenSSL and NDK. Is this now changed? Do they now use hardware accelerated crypto or not? What's the status?
Actually, I haven't looked like into like comparing the speeds or like of the old and the new implementation, so I can't tell you that. But I talked to some people at this year's Google I/O, and they told me they've done like a completely rewrite of these like keystore daemon and the keystore API. So I think for me, what I experience is pretty fast and straightforward. So maybe you just try it out and check back.
Hi, thanks for an amazing talk. So basically my question is, so all those flows that require like fingerprint authentication, so suppose we test them with UI tests, with Espresso or something, are there really tools or any approaches to integrate those screen flows into UI testing?
Yeah, actually, I don't think that there are great like solutions to test like this authentication flow, but actually I have to admit that I haven't like looked into like specific testing purposes there. So there may be, but actually what I found there wasn't like to be very testable, because it like depends on the phone, and because we have like this deep integration with the hardware there to encrypt and decrypt the material and like fetching it from the trusted execution environment. So yeah, I unfortunately I can't tell you that because I haven't looked into it.
Yep. Thank you.